Hi guys, and welcome back to the third lesson on area. In this lesson we're going to learn about how to calculate the area of simple shapes. In the next lesson we will look at calculating the area of composite shapes, but today we're just going to look at simple shapes. So we're just going to go through some of the basic rules for calculating the area, and then we'll do a couple of examples. So to find the area of a rectangle we do length times width, our length times width. The area of a triangle equals half base times height. So there's two ways you can do it. You can multiply these together and then half your answer, or just half one of them and then multiply that by the other one as well. So there's two kind of ways there you can do it. Area of a parallelogram or rhombus. Now a rhombus is like a parallelogram except that all four sides are even in length, but you can still use this rule to help you calculate it. And we'll do base times height. Now it's really important that you realize that the height is from the two parallel lines, not the length of this side length, but the distance between the two parallel lines. And you can see here that it is perpendicular to the baseline. And then we find the area of the kite and the rhombus. So to find the area of the kite, and like I said before, we can use this to find the area of the rhombus as long as all four lengths are the same length. But we do half times x and y, so that's the distance between the points, the opposite points. So again, just like with the triangle, we could do half times one of the lengths times the other one, or we can do x times y and then divide that by 2 as well. So there's the two ways that we can kind of calculate it. The area of a trapezium. Now a trapezium has only one set of parallel lines, so it's different to calculating the area of a parallelogram, which has like two sets of parallel lines. As you can see here that these two lengths here are not parallel. So what we do is we calculate half a plus b, so we add a and b together and then we half that, and then we're going to multiply it by the height here. The area of a circle is pi r squared, so a little bit different to perimeter. Perimeter is 2 pi r, so 2 times pi times the radius, and in this case the area equals pi times the radius squared. Now to calculate the area of a sector or part of a circle, you would go the degrees, so however many degrees is in that part of the circle, divided by 360. And that will tell us what fraction of the circle we are working with. And then we're going to times that by pi r squared. So now we're going to calculate the area of a couple of shapes. So let's calculate the area of this kite, and the rule for that is half times x times y. So we go half times 5 times 8, and so you could go 5 times 8 is 40, and 40 divided by 2 is 20. Or you could also go half times, I'd go half times 8, which is 4, and 4 times 5 is 20. So you get that answer of 20 centimeters squared. Now don't forget, when working with measurement, you always need to include that unit. Do not forget that. And if it's area, you need to include the squared, because we're talking about a squared area. Okay, let's calculate the area of this circle. So area equals pi r squared. Now the distance here that we're seeing is actually the diameter. The radius is halfway, so we have to calculate the radius by dividing the diameter by 2, which means we go 12 divided by 2, which gives us the radius of 6. So area equals pi times 6 squared, which gives us an answer of 113.10 centimeters squared. Now don't forget, don't use your knowledge of pi as in don't just write 3.14. You need to put in that pi symbol into your equation, or you are going to get the incorrect answer in terms of your decimal places. The last example is calculating the area of this sector. So we have an area, a fraction of our circle, and we've got 125 degrees. So what we do is we use this rule here, which is the total degrees that we have divided by 360 times by pi r squared. So we go 125 divided by 360 times by pi times by 10 squared. Now we don't need to half this because it's already the radius. So what we end up with is 109.08 centimeters squared. Hopefully you guys understood that. We didn't do examples for all of the formulas that we learnt about, but if you do have any questions, please make sure you ask and we'll answer those questions. Otherwise, enjoy doing the questions and I'll see you in the next lesson. Thanks, guys.